was making a video going over the connection between a function's graph and the graph of its derivative, showing how you can see increase and decrease in the function and positive and negative in the derivative, and trying to make the jump between those two ideas. And I was using this example that I came up with on Desmos.com, where I have f of x is this cubic polynomial in red, and it has intercepts at -2 and +2. And when I first gave a quick glance of it, it looked to me like the max and the min were at -1 and +1. But then after I recorded the video, I noticed that that is not exactly what it is doing, that the max and min are a little off from that, which I should have thought about because the derivative is 3x squared minus 4, which would give you max and min at ±2/√3 instead of negative and +1. So in my video, I made up this example here. I just drew a graph to explain this concept, and I kind of forced what I wanted. But after the video, I started thinking, well, is it actually possible to generate a cubic polynomial that meets the criteria I was looking for? And I actually tweeted this out. Is it possible to generate a cubic polynomial that intercepts at ±2 and a max and min at ±1? And Tom Edgar, one of the editors of Horizons magazine, jokingly gave me f of x being 0x cubed plus 0x squared plus 0x plus 0, which, is not cubic, but it's just a joke. So anyway, I was just thinking, is it possible? And I don't think it is, and I'm going to show you why. Alright, so let's let f of x be a cubic polynomial where we have intercepts. We know we have intercepts at ±2. We don't know what the third intercept is, but hopefully we can figure out what it should be. It gets us the min and max the way we want it. Now if I FOIL this out, I should get something like this. And so then when I take the derivative, I end up with this expression, k times 3x squared minus 2ax minus 4. Okay, now I want this to be 0 when x is ±1, right? Because that would give me my min and max. So we want f prime of 1 and f prime of -1 to both be 0. So when I start doing the algebra on that, now the constant k is not going to really affect the graph. The k value would stretch it vertically, but that's not really going to help us here. So really what I'm trying to figure out is what value of a here will give me 0 with x taking on ±1. Now already I can tell that this is not going to work, because since I have a linear term here, the ±1 is going to drastically change what happens with a. But let's just try it out anyway. So if I plug in 1 in for x, I end up with -2a equals 1, or so we get a equals -1/2. If I let x be -1, in a similar way I end up with a being +1/2. Okay, so I get two different values of a, and unfortunately if I plug in a equals -1/2, that'll just give me the two intercepts I want at positive -2. It'll give me the min value at 1, but it will not give me the max value at -1. And in a similar way, if I let a be 1/2, I get my max value at -1, but I don't get my min value at +1. So I can't meet both of those conditions simultaneously. So the example that I made up in the last video was actually an example that doesn't exist, which I thought was very odd. And I just wanted to share that with you. If you have any questions on this or you have any interest in this, let me know. And thank you for watching.